All the boxes in a certain warehouse were arranged in stacks of 12 boxes each, with no boxes left over. After 60 additional boxes arrived and no boxes were removed, all the boxes in the warehouse were arranged in stacks of 14 boxes each, with none left over. How many boxes were in the warehouse before the 60 boxes arrived? So this sounds like a very tough question. As a question, if I was behind on time, I almost certainly would use this to catch up, either by skipping it or getting out of it sooner. And it's tough not just to translate it, to unpack it, but also seeing what your different options are for scenarios. In other words, it's easy to miss that it's not necessarily true that all of the boxes, all of your 60 boxes that were added, get added to stacks that were there originally. Because if that were true, there's only one possibility, because that would mean that every stack received 2 additional boxes, and therefore there must have been 30 stacks originally. And if that were true, we would be able to answer the question from the prompt, which we shouldn't be able to do. And so you have to see that the other possibility is that some of your 60 boxes get added to your original stacks, but then you have enough boxes left over that you can make some number of new stacks of 14 boxes each. And so based on that, what I might do is try just writing out what are your possibilities for the number of original stacks you can have and the number of new stacks you can have. And so we already mentioned one possibility, which is when I have 30 original stacks and I have 0 new stacks. So the other possibility was I add 1 new stack, and so it would have to be 1 new stack of 14 boxes. Or I could add 2 new stacks, and that would give me 28 boxes, so 2 new stacks of 14 boxes each. Or I can have 3 new stacks, and so that would be 42 boxes. And so I need to, until I get to over 60, I should be able to make these stacks. And so then I can make 4 new stacks, and that would give me 56 boxes. And that's all you can do, because after that, we would have, if we made 5 new stacks, it would be 70 boxes, and we only have 60. So in this case, so our first case was 30 original stacks of 12 boxes each. And so 30 stacks, 12 boxes each, that would be 360 boxes. In this case, so we had 14 boxes that were added to our new stack. And so we have 46 left over to give to our original stack, but they get 2 each get added to a stack. So that means we had 23 stacks originally. And what's 23 times 12? $276. And so in this case, I added 2 stacks with 28 boxes total. So I had 32 left to apply to my original stacks. But I get 2 boxes per stack. So that is 16 stacks. And it looks like I'm going down by 7 each time. So there should be 9 stacks. And there should be 2 stacks originally. What's 16 times? This is going up by the same amount too, right? 84. It's going down by 84. So, or up by 84, depending where you're starting. So what's 108 plus 84? 192. Okay, so these are our options, and that took a super long time. So like I said, if I guess you can find a quicker way, or if you can do what we did here sort of quickly, that's really your best shot for getting this. So statement 1 says there were fewer than 110 before these 60 boxes arrived. And so that means we could either be here where we had 108 boxes, or here where we had 24. So this should be insufficient, because we're looking for how many boxes we had originally before the 60 arrived. So here it says there were fewer than 120 boxes after the 60 arrived. So our total boxes after the arrival, it's not this number here plus this number here. It's just this number here plus 60, right? Because it's just our original boxes plus the 60 new ones that arrived. And so here we were at 84 boxes. After the arrival of our 60. And here we would have 108 plus 60, which is 168. So we would be over. So that means this is our only possibility here. And so statement 2 is sufficient. And technically our answer, it's not our 84. Our answer is our 24, because that's the number of boxes we had originally. So B, though, is the answer. Tough question. Long question, most importantly.